This is section 10.3, part 3. All right, so we've looked at one example of testing a hypothesis for population mean. We're just going to look at another example in this video, and that more about significance will come up in our final video. All right, so here is another example. A young man decided to enroll in a reading course that allegedly increases reading speed and comprehension. Prior to enrolling in the class, the young man read 198 words per minute. The following data represent the words per minute read for 10 different passages read after the course. Does the evidence suggest that the class was effective? So, of course, we aren't given any statistics here, but we will have data, and that's on the next page. All right, so here is our data. We have 10 values from the readings that he did after taking the course, and we just want to know, will this data help us determine, was the course effective, at least from the reading speed. Now, of course, comprehension, we would have to do a different test. All right, so before I go into my calculator, I've got it here ready to go, but before I do that, I want to make sure that I have my null and alternative hypotheses set. So, of course, my null hypothesis is going to be in this case, the statement of no change. This is where I don't know what a population mean would be. I'm not dealing with a population. I'm dealing with a single person. But I want to know, what was the statement of no change? If this class had no improvement, then his mean words per minute was 198. And so we want to know if the program or the class he took improved his score. So to improve, then he would need to be able to read, not null hypothesis again. There we go, that should be a 1. His mean should go up, right? So if I can read faster, just like if I'm driving faster, my speedometer, the miles per hour, increase. If I'm reading faster, then my words per minute increase. So we want greater than 198. All right, so since we have data, we could go in and actually just put our data in and do the 1var stats and then put it into our t-test with statistics. But that's extra work. That's extra buttons to push. And I'm all about button economy. How many times can I push fewer buttons on my calculator? So I am going to make sure that I've put my data in. And of course, here's my list in L1. I've put these numbers in before we started recording. And so I'm going to go back to stat, over to test, t-test. Now I've got to get back over to data. This is where I did the last example, was stats. Go to data. I need to change my null hypothesis to match the new problem. My list is in L1, so I'm good. Frequency stays 1, don't need to change that. And then my alternative hypothesis, I need to change it to greater than. Then I can calculate, get all my information. Again, you should always make sure that your alternative hypothesis here matches up with what you were meaning your alternative hypothesis to be. Sometimes we go in and we forget to change that. I have done that recently, where I forgot to change the sign, and that's going to mess up. That's going to give you a different value for your p-value, and it can end up getting your problem wrong even when you did the right steps otherwise. All right, so I also have my test statistic here. Of course, we're not doing the critical value method, so the test statistic is really just there. It'll ask you again, it'll say t equals, and then it'll have you fill it in. And again, I'm pretty sure it asks to 3 decimal places, but just round to whatever the homework asks for. Always follow those instructions. You put it to 2 decimal places, it's going to tell you you're wrong, but you're really not. You've just put it in a way that they can't read it correctly. Then our important value, that p-value, That's what we want to look at. And in this case, look at that. That is definitely a small p-value. And so we can say, yes, he did improve. And if we look at the actual numbers, he's reading more than 10 words per minute now after the class. And, I mean, think about it, in an entire minute, that's 60 seconds, but 10 words more on average is probably a pretty good improvement. So the class did help. Now, if he wants to improve again, maybe there's an advanced reading speed and comprehension class that he can take. But for now, when we look at p-value, oops, there we go, versus alpha, then 0.003. Now, we weren't given an alpha. Sometimes we are, sometimes we aren't. But remember, we can always use 0.05. Especially in a situation like this where it's not life or death. 0.05 is perfectly fine to use. So, but even if we did use 0.01, it would be less. So this means we reject the null hypothesis. So it's always important that we look at our p-value, compare it to our significance level. If that p-value is small enough, if it's unusual, it would be unusual for him to have a mean of 208.4 words per minute if he was still reading at 198 words per minute. That would be an unusual result if the null hypothesis was still true. So we have enough evidence to reject the null hypothesis. All right, we'll go to the next slide to write our conclusion. Okay, and again, since we rejected the null hypothesis, then we can say that there is sufficient evidence and again, just as a reminder, it's sufficient because we rejected the null hypothesis. So that's why we're able to say that we have the evidence that we need. So there is sufficient evidence at the alpha equals 0.05 level of significance. And before I go on, let me make one quick comment about this alpha equals 0.05. Be very careful to not say that it needs to be less than 0.5. It's very tempting to lose that 0 between the decimal and the 5. And it's not, it's just a quick mistake that I think people make. To say it with just say 0.5 but mean 0.05. Remember that 0.5 would mean a 50% chance. So that would be saying that we're going to make something significant if there's just anything less than a 50-50 chance of it happening. And of course, I think that none of us believe that that should make sense, but we get in a hurry and we lose that 0. And we go from a 5% chance, like it should be, to a 50% chance, which is definitely not something that we would want to give a 50% chance. Remember, that alpha is a probability of making a type 1 error. That's the probability of vaporizing a live person, if you remember back from section 10.1 videos. We don't want to give ourselves a 50% chance. Like, there's no test need for that. You just flip a coin, and if it lands on heads, you do one thing, and if it lands on tails, you do the other. We don't want that kind of result. So instead, we want to make sure, just again, keep it in mind, not that you think that 50% is a decent significance level, but that you remember that 0.05 is what we want, not 0.5. Okay, side tangent complete. Let's go back to our conclusion. So, I didn't actually put this right. There we go, is sufficient evidence at the alpha equal 0.05 level of significance to suggest the reading class was effective.